Hello and welcome. In this video, you'll learn one way to reconstruct 3D objects with a stereo setup using MVTec HALCON. 3D reconstruction is used, for example, to provide point clouds for matching in pick-and-place applications or completeness checks, for measuring objects, or simply for visualization. So, how does 3D reconstruction work? For the approach shown in this video, you can use 2 or more cameras. You can even mix different camera types with different lenses, like, for example, telecentric lenses. For the approach to work, the stereo setup needs to be calibrated. Have a look at the corresponding video if you haven't seen it yet. To reconstruct surfaces, the algorithm looks for correspondences in the images. Thus, disparity images are computed for image pairs. Disparity represents the distance between corresponding points in a stereo image pair. Note that the accuracy of the disparities directly influences the accuracy of the depth information during reconstruction. The pairs in a setup should provide different points of view. If one pair does not see a certain area of the surface, it is covered by another pair. An important aspect of stereo reconstruction is the texture of the object. If there is no texture, the search for correspondences is ambiguous and thus does not provide enough information for a reliable reconstruction. To provide texture, you can use a pattern projector, like the one installed here. The positioning of the cameras is another important aspect. A larger triangulation angle increases the distance resolution. However, this can make the search for correspondences harder because the images appear less similar. Thus, a smaller triangulation angle can produce more complete results. Now let's have a look in HDevelop. First, we read in the camera setup model we saved after calibrating the setup. Based on this camera setup model, we create a stereo model. There are 3 methods available. With Points 3D, we can reconstruct 3D points by intersecting lines of sight from point correspondences. In this video, we will focus on surface reconstruction using the pairwise and the fusion methods. The fusion method uses the pairwise method as an intermediate result. So, let's have a look at the pairwise method first. To start with, we specify the camera pairs by inputting tuples of camera indices. Note that the number of pairs linearly affects the runtime of the pairwise reconstruction. Thus, you should use as many as needed and as few as possible to balance the runtime versus completeness of the surface reconstruction. Next, we have to specify a bounding box. The reconstruction is limited to the space inside this bounding box, which reduces the runtime and noise. Additionally, if the minimum and maximum disparity are not given explicitly, they are estimated based on the bounding box. The procedure Estimate Bounding Box 3D Reconstruction is a useful tool to find initial bounding box parameters. It estimates a bounding box based on the intersecting cones of sight of the cameras and the world plane. The world plane should be the plane where the reconstructed objects are placed. For this procedure to work, it is necessary to set a suitable plane as the reference coordinate system within the camera setup model. Here we use the calibrated pose of the first calibration plate for the reference coordinate system. The bounding box is given as x, y, z coordinates of 2 opposing corners. You can and should adapt it. Especially for the fusion method, a tight bounding box around the reconstructed object is recommended. Another important parameter is the disparity method, which is used to compute the disparity images. There are 3 methods available. Have a look at these operators and their respective examples in HDevelop for much more information. To inspect intermediate results like the disparity images, we have to enable the persistence mode. Note that this will increase the required memory. Then we can later call getStereoModelObject to retrieve disparity and score images. Thus, you can fine-tune the disparity method parameters. Now, with all these parameters set, let's acquire some images. First, let's reconstruct my hand. For this, we concatenate the acquired images and call reconstruct surface stereo. As a result, we get the reconstructed 3D scene. While the result of the pairwise reconstruction is well suited for applications like matching, the fusion method has many advantages over pairwise reconstruction. For example, the fusion method offers improved noise reduction and outlier suppression. Moreover, this method will try to produce a closed surface. In general, the visual results of the fusion method are much better. Additionally, with the surface fusion method, it's also possible to directly add color information to the point cloud. To learn more about the involved parameters, have a look at the HDevelop example Reconstruct Surface Stereo Fusion Workflow.hdef. It shows the results when setting certain parameters too low or too high. Now let's have a look at some limitations of 3D reconstruction. This flask is made of glass. Because of its irregularly reflecting surface and its transparency, the 3D reconstruction is incomplete. For 3D reconstruction, surfaces should reflect light diffusely, such that the surfaces look the same from different angles of view. Shiny, mirroring, and transparent surfaces cannot be reconstructed with this technology. Lastly, this power adapter doesn't have any structure by itself, and I switched off the random pattern projector. Thus, the 3D reconstruction fails for the most part. When switching the pattern projector back on, the reconstruction performs much better. This concludes this video. We hope this tutorial gave you a good introduction to 3D reconstruction, its possibilities, and how to use it. You can download the HDevelop example shown to try it out for yourself. For much more information on the topic, have a look at the chapter reference of 3D Reconstruction Multi-View Stereo, the documentation of Reconstruct Surface Stereo, the solution guide on 3D vision, and the provided HDevelop examples. Thank you for watching.